Hello grade 8 learner! Welcome to another video lesson in mathematics. In this video lesson, we will be discussing about how to divide rational algebraic expressions. It's another great day to learn, so grab your pen, paper, and module as you start watching and learning from this video lesson. This lesson is based on the K-12 curriculum learning competency. The learner performs operations on rational algebraic expressions. By the end of this lesson, you, the learner, should be able to follow the steps in dividing rational algebraic expressions, apply appropriate factoring techniques while dividing rational algebraic expressions, and to apply the process on given rational algebraic expressions. Let's begin the lesson with a review on how to divide fractions. For example, we have 2/3 divided by 5/7. Our first step in dividing fractions is to change the second fraction to its reciprocal. Then we proceed to multiplication to get the result, which is 14/15. If the fractions we are dividing have common factors, we can simplify the process. First, we get the reciprocal of the second fraction, then change the operation to multiplication. Before we multiply, however, we rewrite the expressions to their factored forms to cancel the common factors. Multiplying the remaining expressions results to 9/4. Take note of this process as we discuss how to divide rational algebraic expressions. In dividing rational algebraic expressions, we use the following formula. A over b divided by c over d is equal to the product of a over b times d over c, which results to the product of a and d over the product of b and c. Just like in multiplication, division of RAE follows the same steps as division of fractions. Let's see an example. To divide negative x over 3 by y over 5, we first get the reciprocal of the second RAE, which is 5 over y. Then change the operation to multiplication before multiplying the numerators and denominators together to get the product, which is negative 5x over 3y. Take a look at the following examples. For example, we are going to solve for the quotient of 6 over 20y squared divided by 8 over 30y squared. The first thing we do is to copy the dividend, get the reciprocal of the divisor, then change division to multiplication. Remember that the first term in the division sentence is called the dividend, while the second term is called the divisor. Therefore, we copy the dividend, which is 6 over 20y squared, get the reciprocal of the divisor, which is 30y squared over 8, and then change the division sign to multiplication sign. We are now ready for the second step. The next step is to rewrite the numerators and the denominators of the RAEs into their factored form. As you have learned in the multiplication of RAEs, factoring the numerators and denominators can help us identify common factors that we can cancel out later in the solution. Thus, 6 over 20y squared is factored out as 2 times 3, over 2 times 10y squared. For the second RAE, 30y squared over 8 is factored out as 3 times 10y squared over 2 times 4. Take note of the common factors between the numerators and denominators. After writing the expressions in their factored form, the next step is to cancel out the common factors between the numerators and denominators. We see that the numerator of the first RAE and the denominator of the second RAE has a common factor of 2, so we cancel those out. Looking at the denominator of the first RAE and the numerator of the second RAE, we have 10y squared as a common factor. So again, we cancel those out. We check also if there are any remaining common factors within each RAE, but there's none, so that means we're ready for the next step. After we've canceled out the common factors, we proceed to multiplying the remaining expressions. For the first RAE, what remains is 3 over 2. And for the second expression, what remains is 3 over 4. Following the process of multiplication, where we multiply the numerators and denominators together, we get the final answer, which is 9 over 8. Just like in multiplication of RAE, we have another way of dividing RAE. We can also simply multiply the divisor and the reciprocal of the dividend instead of writing out the factored forms of the expressions. Dividing RAE this way will still give you the same answer. However, this method will give you expressions with large numbers to work with. Also, it may not be easy for us to simplify the expressions that result from this method, especially when we are going to work on polynomials in the RAEs. Let's take a look at our next example. We are going to divide x squared plus 3x over x squared minus 9 by x squared minus 5x over x squared minus 8x plus 15. We begin by copying the dividend, getting the reciprocal of the divisor, then changing the operation to multiplication. Looking at the expressions we have, it's going to be difficult to multiply the numerators and denominators together, so we instead write the factored forms of the numerators and denominators. Observe that we use common monomial factoring to factor out x squared plus 3x and x squared minus 5x. We also apply the appropriate factoring techniques for the denominator x squared minus 9, which is a difference of 2 squares, and the numerator x squared minus 8x plus 15, which is a quadratic trinomial. Take care to note common factors between the RAEs. After factoring out the expressions, we now cancel out common factors. We begin by canceling out the common factor between the numerator of the first RAE and the denominator of the second RAE. That common factor would be x. Next, we cancel out the common factor between the denominator of the first RAE and the numerator of the second RAE, which is x minus 3. Lastly, we check each RAE if there are any remaining common factors within the expression. In the first RAE, we see x plus 3, so we cancel those out. In the second RAE, we see that there is the common factor x minus 5, so we cancel that out as well. After canceling out the common factors, we multiply the remaining expressions. But if we look at our solution, what remains when everything is cancelled out? Is everything really gone? Of course not. Even if every expression is cancelled out in our solution, there is always that invisible, often overlooked, and constant factor which is 1. 1 will always be there as a factor if everything else can be cancelled out. So from our expressions, what remains is 1 over 1 times 1 over 1, which results in 1 over 1, or simply 1. This only shows that even if a problem looks complicated, there can be a simple answer for it. How about you? What have you learned from this example? That's the end of our discussion on dividing rational algebraic expressions. We hope that we have made the lesson clear to you. If there are some things that you still can't follow, you can rewind this video, read your module, or ask help from your teacher to improve your learning. To check how much you've learned, try solving this problem. Divide x minus 2 over y squared plus y by x squared minus 4 over y plus 1. Pause this video and solve before we move to the answer. Done? If you got the RAE 1 over xy plus 2y, you got the correct answer. Good job! If you got a different answer, check the solution to see where you went wrong. Mistakes are never permanent if you take the time to correct them. Congratulations for finishing this video lesson. As the famous scientist Albert Einstein once said, learning is an experience. Everything else is just information. So keep on practicing what you have learned, dear learner, so that you can widen your experience. We'll see you again in our next video lesson.